the silence of the far side. Understanding the Artemis II communication blackout as the Artemis II mission pushes humanity further into deep space. The crew is set to encounter a phenomenon that is both a technical hurdle and a profound psychological milestone: total radio silence. As the spacecraft orbits the moon, there will be a specific window where the lunar body itself acts as a physical barrier, severing all communication between the astronauts and mission control on Earth. The 40-minute blackout at approximately 23:47 BST on Monday, the Orion capsule will pass behind the moon. For roughly 40 minutes, the radio and laser signals that facilitate constant contact with NASA will be blocked. During this time, the 4 astronauts will be completely isolated from Earth, traveling through the darkness without the comforting voice of mission control in their ears. This period of solitude is not merely a technical gap. It is a moment of intense psychological isolation. Artemis pilot Victor Glover has framed this upcoming silence as a moment for global reflection, inviting the world to send good thoughts and feelings during the window when the crew is out of reach. A legacy of isolation. From Apollo to Artemis, this experience is not new to lunar exploration, but it carries a heavy historical weight. Over 50 years ago, the Apollo astronauts faced similar periods of disconnection. The most famous instance occurred during the Apollo 11 mission in 1969. While Neil Armstrong and Buzz Aldrin were making history on the lunar surface, Michael Collins remained in the command module, orbiting alone. As he passed behind the far side of the moon, he lost contact with both his crewmates and Earth for 48 minutes. In his memoirs, Collins described feeling truly alone and isolated from any known life. Yet he noted that the silence brought a sense of peace and a rare reprieve from the constant stream of instructions from mission control. The technical challenge. Tracking the unknown while the astronauts experience silence, the teams on Earth will experience tension. At the Goonhilly Earth Station in Cornwall, England, engineers will be monitoring the Orion capsule's position with high-precision antennas. This is the first time we're tracking a spacecraft with humans on it, says Matt Cosby, Goonhilly's chief technology officer. We're going to get slightly nervous as it goes behind the moon, and then we'll be very excited when we see it again. This nervousness highlights a critical distinction between current missions and the future of space exploration. For Artemis II, a 40-minute blackout is a manageable part of a flight profile. However, for the next phase of lunar exploration, it is a significant obstacle, solving the far side problem as NASA and other global agencies transition from visiting the moon to staying on the moon. Continuous communication is no longer optional. It is a requirement. To establish a sustainable lunar base and explore the far side of the moon, we cannot rely on intermittent signals. To address this, several initiatives are currently in development. Satellite networks. Programs like the European Space Agency's ESA, Moonlight aim to deploy a constellation of satellites around the moon. Relay capabilities. These satellites will act as communication relays, looking around the moon to pass signals from the far side back to Earth. The goal is simple: to turn the moon from a place of isolation into a connected frontier. Conclusion: the upcoming 40-minute blackout during Artemis II serves as a bridge between the heroic, isolated era of the Apollo missions and a future of permanent lunar habitation. While the silence will be profound for the crew, it highlights the urgent technological need for a lunar satellite network to support long-term human presence.